Hi, in this video we're going to learn how to use the Line Struct in the RhinoCommon, and as we have learned how to use the points 3D struct, we can now easily connect 2 points using a line. So let's head to the RhinoCommon API website and let's search under the geometry, the geometry namespace. Let's find the Line Struct, and here let's read this RhinoCommon website quickly and see how can we use it. So it appears that the line is a struct, so usually the construction method will be the same as the point 3D. So we're going to create a line object using the constructors under the Line Struct, which are using 6 doubles, which mean the 3 coordinates of the first point and the 3 coordinates of the second point, or using 2 point 3D objects from 2, or using a point 3D start with a vector direction and a length, or using a point 3D start and a vector 3D span. Also, we'll have some properties. So on set, it gets a line segment which has a point 3D dot onset endpoints. So the points using or making this line are onset points. Or we can find the bounding box that includes our line, we can find its direction, and here we have to learn what does the property do. So if it says gets, then we can set or change the property of this line object, but some will give us the ability to get or set some of the object's properties, like from x means from the starting point, or the starting point we can change, set the x coordinate of it or get it, we can do both. And from y, from z to 2x, 2y, 2z, we can get or set these properties. And we have the length, so we can get the length of this line object. We have some methods like finding the closest point, like finding the distance to, which is the shortest distance between a line segment and a test point. We can extend the line with a double start length, so it's like extending the line from its start and extending its end. We can do both actually, or we can do one of them. If we don't want to extend the start, then we'll make the start length double equals to 0, and if we don't want to extend its end, we'll make that double equals 0. And we'll have some other methods like extending through a box, like flipping the line, like a maximum distance to a point or to a test line, or we can get a point at some line or a point at a length. We can convert this line to a NURBS curve, and finally we can transform the line. So what can we do now? Let's try creating 2 points and find how can we construct a line between them. Let's create those 2 points. So we'll say point 3D, point A equals to a new point 3D. Let's say that it will be at the origin. So in this case, we can just write point 3D dot origin. We can use this property from the point 3D struct directly, and then let's copy this term and call it point B, and here we're going to create a new point 3D with three doubles, let's say 5, 5 and 0. And now let's see how can we create a line between them. If we go here to the constructors, we will open the tab, and here we'll find what it returns. So it returns a line object, and inside are the arguments. So all we have to do is to create a line object, and let's do that easily by writing line and give it a name, line AB equals a new line. And if we open the brackets, we'll find 4 overloads of how to create it, and those are exactly the same for constructors of line of a line object that we find on the RhinoCommon. So we need to use 2 points. So here we'll just write point A and point B, and then assign this to our output. Say A equals line AB. Maybe we need to show our points at first, so let's assign point A to A, point B to B, and the line to C. And here if we run, there will be an error because we don't have the A, B and C, and once we show them, then the code runs correctly and we'll find our 2 points and a line between them. Now what if I want to find a point or to get the distance of this line? In order to do so, let's always return to our line struct and learn at first how can we do so. And usually the length is in the properties of the object, and the length returns a double. So it is really important, because if you're going to add a variable and call it the length of this line, you need to write the data type before this variable. And here you need to always go back here at first until you learn and just get the logic of how to use all of these methods and all of these properties. So here we're going, and by the way, again, we didn't find a static keyword here, and so we're going to use the object itself. So if you want to find the length, we write double length AB equals, and here we'll write line AB dot get length, and that does not work. Okay, it's not dot get length, it's dot length. Yeah, it's dot length and not dot get length. So all we have to do is to remove this and assign another output and call it length AB. And if we run this code and add the D output, yeah, maybe we have to remove the brackets and it will give us the result. If we add a panel here, it will give us the exact length of this line. If we change it, let's say 500, the line changes, and of course the length will be 5. And if we change this to 7, the length will change and be longer than the 7 length that showed when this was 550, and so on. Now of course I can get the x coordinate or any coordinate of one of the points. So if we go back to the website, we'll find here the to x or from x. So if I want to get the x coordinate of the second point, all I have to do is, and of course it's a double, so we'll say double 2x equals line AB. And if you don't know if you have to write the line AB, the object's name, or the struct's name, all you have to do is to go back, open the property, which is 2x, and if you don't find the static keyword, you'll need to use the object's name. So here we'll say line AB dot 2x, and here we'll add another output and call it 2x and add it here. And if we run now, of course it will give us 5, right? And if we say the 2y, it will give us 7, right? We can see it here. Now what if I want to extend this line? Let's try it. And again, the first videos I'll be showing you using the website itself in order to get the logic, and then we may be faster in this process actually. So if I want to extend the line using 2 doubles, I'll open this, and here we find a different data type, which is a boolean, so it returns true or false. So it either extends the line or it doesn't extend it. So here what we do is we don't create a new object and extend the line, extend the new object. All we have to do is, after creating the line, we'll say line AB dot extend, and we're going to add, if we need to, let's say 2 at the start and 0 at the end. Now I don't have to assign any output because this method goes on the exact same object, and the result will be the result of C, which is line AB, will be line AB after extension. So if we run, we'll find that the line is extended. Okay, cool. Now let's see how to get a point at a certain length of a line. It will of course return a point 3D object, and it will happen using the object's name, which is our line AB dot point at length, because there is no static keyword, and inside we write the distance that we want to find the point at. So in order to do so, let's first remove the extend function, and here we can create a new point 3D, call it point at AB, and here it will be equal to line AB dot point at, but we need to find it at a certain length. So here the length of the line was around 8, so if I want it at 5 exactly and run this, and here we're going to add another output called point at AB. If we add this output here and run it, it will give me the point at a certain length that I need. And we can of course use our inputs, so point at, if we write point at length x, and here if we write from 0 to 8 and rerun this and choose x to be a double. Now let's see what's going on. If we connect a point component here to CR point, of course it's at the 0 because we're starting here, and as we go the point is going, and as I remember the length of this line was around 8 point numbers. So now what if I want to reparameterize my line, and instead of finding a point at a certain length, I can relate the point to a domain from 0 to 1. So let's think of the length of this line as 1 unit. This is a very easy way if I want to find a point at the middle of our line, or to find it on the quarter of our line, or so on. In order to do so, we will need to use a geometry struct or class, I'm not sure, called interval, and we'll find it here. Okay, interval, yes, it's a struct, and it can change the domain of our line. So in order to do so, we can just type, after creating the line, we will say line ab dot domain, not dot domain. Okay, this will not work this way because the domain property is not included in the line struct. So in order to do so, I can transform my line to a NURBS curve which has a domain property, and let's check how can we translate line to a NURBS curve, and we'll find it here in the line, in the methods of the line, and to NURBS curve. So we will create a NURBS curve actually. So first we'll write here NURBS curve line, NURBS curve line curve equals line AB dot to NURBS curve. And in this case, if we try to change the domain of this NURBS curve, we'll just write dot domain, and here we'll find our property that is called domain, and we'll say equals new interval from 0 to 1. Here we have changed the domain of our line curve, and to check this we need to go to the NURBS curve class and check the domain property, and we'll find that it gives us an interval. So it returns an interval as a data type. So here we maybe need to say interval line curve dot domain, or we can just do it as it is. In this case, instead of getting the point at length, we'll find the point at x, and x can be anything in this case, right? So it can be 0, it can be 0.25, it can be 0.5, it can be 0.75, and finally it can be 1. And here, if we connect the 0, the point will be at 0. If we connect the 0.25, it will be exactly on the quarter of this line. If we make it here, it will be exactly on the middle of this curve, and so on and so forth. So this is an easy way to reparameterize our line, and instead of finding a point at a certain length, we find it, let's say, on the middle or the quarter or anything easier. This is actually used a lot in the parametric modeling. So you will need to do some exercises about the line struct. You may need to try a lot of these. You may need to try to transform it, or let's explain the transformation method in another video because it is somehow, let's not say complicated, but it's not straightforward. But still, you will have a lot of methods here to try, and what I'm trying to teach you in this playlist is how to open each method of these and try to read them here. It's how to read, how to use it by the object or the struct or class name, and what does it return, which is a bool, and if it returns a bool, what does it mean? Does it mean that I need a true or false value? Of course not. It usually means that this method will work directly and will affect our object in a straightforward way, and you do not need usually to create a new object and use a static method on it if we're calling the line or the point 3D or the vector 3D and a lot. But when we're working with the curve or the brep, we'll find that we need, of course, to assign or create a new variable, although it's a static method that will be used on this object. But let's not really think of this part right now. Let's focus on taking the steps step by step, and I hope you find these videos really helpful. And if you have any questions, please write them in the comments, and if you like the content, please subscribe to our channel and like the video and tell everyone you know. Thank you, and see you in the next video.